Okay. Hello, my friends, to this webinar. This webinar is on land cover dynamic analysis for climate change impact with Python and Rasterio. Okay, so what we are going or what is the purpose of this webinar is to evaluate the impact on the land cover due to due to the climate change. Okay, so we are going to assess abandonment. So that is mostly when people who do not have enough water, so they have to abandon crops. And this was really a hard task because we have to assess the abandonment of three. Because when you have temporary crops, you can it is not the sometimes it's not the fundament by the lack of water resources that you have one field, an empty field. Okay, because it can be also that the farmers didn't crop that year. But when you are talking about trees, okay, the abandonment is more uh, is drastic or is more noticeable because you have dead trees when you before had a a tree farm or like crops, tree with crops. Okay, if you have understood that, please type one. I want to ask you about the your Python skills, so please type which is your Python level. Okay, I will download the file for this webinar. Okay, which is your Python level. Okay, through the chat, please. Okay, I have downloaded the material, and this downloaded the material. uh, I will extract here, and then this folder I will paste it here on my documents. Okay, it has to be in the documents. 6 out of 10. Okay, Eusebius, about the rest, please. Which is your Python experience? 5 out of 10. Okay, for the rest, 4. Okay, so let's see. Let's start with Anaconda Prom. CD documents, CD webinar. Okay, and here we launch Jupyter Lab. Okay, we have a lot of coding, and I think that you are okay, and really you are interested in see the coding about the coding discussion. So for the people that cannot stand very well with the coding or the steps, because this is large, okay, I would like that you will follow the tutorial, okay, or the webinar, and then you later on you can type with more calm. Okay, so and I'm Eusebius. I'm counting that I can I can keep up I can keep up with the code with you. Okay, so okay, what do we have? We have a raster, and here in those rasters we have, for example, we have some June image for year 2013 and 2014, and for year 2023 and 2024. Why? Because I'm going to explore the change in between 10 years, okay? But I'm also interested in having an average of the NDVI because there could be some outliers or some other stuff. that can make okay, by having a mean, okay, the outlier impact will be lower, okay. So if you have understood this, please type 2. And then here on scripts we are going to launch a new part 1, okay. Great. Yes, 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 the input data is on the whoa, it's here. Okay, so you go here and then you put Hatari Labs. Yep. And then from that you download it, you extract it, and then you put it on the scripts. Okay, great. So let's see about part 1. Okay, so let's import the well, we are going to work with hard stuff. Yeah, it's Hatari Labs with capital H. Okay, so let's see. Let's import the files. Import Rasterio. Import Rasterio. Import OS from Rasterio. Import plot from Rasterio. CRS. Import CRS. CRS. Import matplotlib.pyplot as plt, import numpy as np from rasterio.mask. Import mask, we need to do that to crop the raster from rasterio.var. Import calculate default transform reproject and resampling. Okay, import geopandas as gpd, and from affine is what is affine? Affine is a library that is related uh, to the conversions in between the array. Okay, that is responsible uh, of moving from the array to raster. Okay, so that is doing the transformation. Okay, so if you don't have any other, okay, for example, I don't have rasterio, so I just insert one and then I pip install rasterio. Okay, I have to run this once. I have to run this once. Okay, so until, and maybe I won't have geopandas as well, so geopandas. Okay, so okay, great. So here I have raster. If you have any questions at any time, please let me know. Okay, so in AOE path is the AOE to the to a shapefile that has this place in Turkey, that is the exit area about.shapefile. Okay, and then we have the ndvi date list. Okay, is x for x in os list dir rst. Okay, and if because we need to do this list comprehension. Why? Because Jupyter is making some default folders that actually, even though that you only have the raster folders, okay, it will create some temporary folders like Anaconda Pro, so okay, projects. And in order to meet that, so we are interested in just the folder that has this score sign in it. So this will be the ndvi date list. Okay, so these are the dates. Okay, so we are going to create a total ndvi, and this is a function. Let's say the def create total ndvi of ndvi date. Okay, total path is equal to os path join of the folder rst and the ndvi date. Okay, so this is the total path to the raster. So we have the band for list. Okay, why band for list? Because it's a list that only have one value, because there is only one band for every folder. Okay, uh, x for x in os is dir of total path if x ends with okay, if ends with b04 dot diff close. Okay, great. So this is will give you the band 4, and this that is red, and this will be near the near infrared. This will be b5. Okay, that is great. Okay, and now we got the band 4. Okay, the band 4 is equal to Rasterio open on os path join of total path band for list of 0 and band 5 is band 5 list. Okay, so this will give us the raster object. Okay, but then we have to say then okay, the Rasterio object, and then we have to read the band. There is only one band as type of float of 64. This is for the red, and this is for the near. This is band 4, and this is band 5. Okay, so great. So now we are going to do the ndvi is equal to np where, so we use numpy here, uh, where the when there is no where the near plus red is equal to 0, so when there is some empty values, 0 point, So it will have a value of 0. Otherwise, we'll have a near plus minus red divided by near plus red. Okay, near plus red. Okay, so with that we hope that we can overcome the empty values here. Great. So now we are going to create an image ndvi image is equal to rasterio dot. Okay, so we are going to store the. Okay, so we have calculated the ndvi, and then we are going to store that where we are going to store in raster, and then here in ndva total. Okay, because still this is a total ndvi that is in geographical coordinates. Okay, total. Okay, and then diff. So it will create a TIFF file, okay, with the ndvi dot with the ndvi date, okay. The driver will be TIFF. Okay, the width, something is going on here. This is W. Okay. Was looking for the W. I don't know. Okay, the driver is TIFF. The width is equal to band for width. Okay, comma, the height is equal to band for height. We assume that both bands has the same dimensions. Okay, count is equal to 1, CRS is equal to band for CRS. Okay, transform is equal to band for dot transform. The type is equal to float of 32. Okay, great. So, and then we store the ndvi image there. Ndvi image dot write ndvi on the band 1 and ndvi image close. Okay, so this function will create the ndvi image and it will store that as well. Okay, so for ndvi date in ndvi date list, create total ndvi, okay, of ndvi date. Great. So there is a warning here, but it works. I think so. So we have created, so if we go to total, so it has created an ndvi for all the 4 dates. Okay, and that is amazing. Great. So now we have to reproject the raster. And why we have to reproject the raster? Because we are going to work in UTM, because we are going to deal with the pixel size. Okay, so the pixel size when you are working in geographical coordinates is awful. Okay, so we want to work with meters as the unit length. Okay, so for that we are going to do reproject raster of NDVI, okay, in NDVI is equal to ospat join of RST of the NDVI total, okay, NDVI plus TIF. Okay, great. So that will be the in NDVI, okay, and we have another that is the out NDVI, okay, that it will be the reprojected one. So it will be in NDVI repro. Okay, so we with Rasterio dot open in NDVI as SRC. Okay, so we have the destiny CRS. Okay, so we are going to transform to EPSG of 32637. Okay, so transform with height is equal to Allison asks if this transformation that can be avoided transformating the layer before running the yes, okay, great question, Allison. We need to transform that because when we clip, okay, when we clip the raster, because this is a total raster, when we clip it to the area of interest, okay, not all, okay, even though that all the raster has the same dimension, when you clip it, not all will have the same dimensions on the clipped part, okay, because due to the due to the because the the exchange, okay, the location of the raster do not coincide. Okay, do you understand that, Alison? Okay, so that is why we need to transform and then we need to clip it, okay, in order to assure that all the clipped NDVIs have the same dimension and they start from the same points. Yeah, otherwise this will be much okay, I like your question because otherwise this this will be much easier to do. Okay, it took me some time to develop this code. Okay, so this will be src.crs destcrs src width src height and then src bounds. Okay, no arcs is equal to src.meta.copy. Okay, so we extract the meta and then we know arcs dot update and then we update the meta to CRS Okay, and this will give you more control of what is going on the transformation. Okay, so and it will give you by sure more tools. Transform. Ah, this was actually a dictionary. Okay, great. And now say okay, and then we with rasterio.open out NDVI as DST for in range of 1 of src.count plus 1. Well, this is only one band, but I don't know why I came with this. Okay, so we reproject source. Okay, so we say the rasterio dot band of src, the band, the first one, destination is equal to rasterio dot band of dst dot 1 comma comma src transform src dot transform src dot crs is equal to src dot crs comma dst transform is equal to transform dst crs is equal to dst.crs. Okay, resampling dot nearest. Okay, so this actually do the resampling. Okay, and do the resampling to the this does the reprojection. Okay, to this system. Okay, so let's see if this works for ndvi date in ndvi date list 2 points. Oh, yeah. Create total ndvi of ndvi date. Okay, great. So we do this and we have created our reprojected ndvis. We guess so. No. Sorry. Reprojected rate. This was the previous reproject raster. Okay, and then we have a error calculate transform. Okay, let's see. we have another error. Okay, so kernel run all cells just to check. Okay, sorry, this was, there was a mistake here. Mhm. Okay, does the reprojection always need to happen because you are ensuring that they are the same moving? Uh, yeah, you. Why I have reprojected? Because I want to have more control on the raster size. Okay, because when you reproject, actually your cells are not, when you do this clipping and so on, your cell sizes actually are, they are not longer 30 by 30, or they are 26 by times 29, something like that. That is why I did the reprojection. Okay, so and here what I find is in dvi repro, I have an error here. This is Rasterio open, but you need to, okay, you need to give the writing permissions and then the no arcs. Okay, this transform is transform is equal to transform dst dst. ah this is destination. Okay, so it has reprojected the raster. Mhm. Great, so that is great. Okay, so now we are going to now we have the reprojected rasters, and then we are going to uh, give our resolution. We are going to resample the raster, okay, but we are going to resample and then we are going to make sure that all the rasters uh, start, okay, and then we are going to clip as well the raster. Okay, we are going to, okay, if you follow me, what we are going to do is that we are going to, okay, to clip the raster, and from the clipping the raster, we are going to provide that all NDVIs start from the same point with the same resolution. And this is really practical because you can work with any raster, and it will do, and then you will get the result will be a raster on your area of interest with the right resolution. Okay, so this is more like quality proof. If you have any questions, please. Okay, out res is equal to 30, bound df is equal to gpd dot read file of AOE path. Okay, xdim is equal to bound df total bounds. Okay, xmax minus xmin ydim and call is equal to int of xdim divided by outRes. Okay, and row is equal to int of ydim divided by outRes. So the print xdim ydim and call and row. Okay, and here you can also change the resolution of the, for example, if you want to change the resolution of your raster, you can change it here. Wait, AOE path. Okay, sorry, is DGC area bound WGS. Okay, so because this AOI has to be in UTM. Okay, I'm going to run the cells again, no worries. Any questions? Okay, I would like that you can introduce yourself, or at least the country from where you're connecting, please. Through the chat. Okay, so here we have the dimensions and the number of rows and the number of columns. Okay, through the chat, please just type from where you're connecting. Okay, from Panama. And now we are going to clip this. Def dot clip raster by mass. Okay, about the rest, please don't be shy. Bound df. Okay, so now again, so we are going to copy the NDVI. Okay, these three lines are the same, so but this will be from repro to clip. Okay, so now we are going to clip the raster. So NDVI src out image out transform is equal to mask of src bound df geometry dot values. Okay, great. Crop through. Okay, Norman from Nicaragua and Eusebius from the US. All meta is equal to src dot meta dot copy. Norman, were you the one that is studying in Germany? Hey, yeah. I did, well, 20 years ago, I did a German course in Bonn that is close to Köln. It was, I mean, I was just 3 months there, but it was such a great place, huh? I like it a lot. I mean, Bonn has its thing, but it was close to Köln, that was a real city, like because Bonn was more like a small city, no? And there were a lot of stuff to do. Mhm. More the shape one. Okay, yeah. Then I moved to Stuttgart, where I did my master degrees there. And it was, well, it was an excellent city. It was really modern. Okay, but it was kind of as well really small because like there were places to go. I know them, but the, like there this as a city was really small. Mhm. If I have done my PhD in Berlin, maybe I would have stayed there because in Berlin is, I mean, there is a lot of things going, a lot of places, a lot of art, culture. There was in Stuttgart and as well in Bonn, but I think that it was like they were really exploring things there. Okay, as this. Okay, this dot write. Okay, out image. Okay, so this is a function that clips the raster. Okay, so when you clip, you have the out image and the out transform. Okay, and then you give the shape, the height of the shape. And well, so far this only clips the raster because there is a next one that will reproject the raster. Okay, so this only clips the raster. Okay, this only clips the raster. So, and then we copy this and then we paste it here and then we clip the raster, and it will, in this folder will have the clipped, but that can have, and those might have different uh, that might have different sizes. Okay, and this is what happened to me because when I clipped the raster, the sizes were different. Okay, great. So here you have ndvi, and this is the clipped. Great. Okay, so now what we are going to do is we are going to resample the raster. Okay, I copy this as well and this is resample raster by params, resample raster by param, bound df, and call and row out res, and this will be from clip. So this is a transform, is affine, and here is where we use affine. Any questions? Okay, take advantage of doing your questions here because is totally free so far. And then I can give you a hint of what is will be your coming work when, because I think that when you are going to have next question of these topics, you will be alone. Okay, the affine is a transformation, and the transformation is related about how do you relate your raster array to your numpy array, your 2D array, to a raster, something that is a geospatial. Okay, no arcs, src.meta.copy. Here is where we give our own sizes, okay, in row and col, and the transform. And here, okay, here is the x min, and this is the y max. So this is x min, y max. This is the lower up. This is the lower up, lower upper corner, okay, and this is where we gave the resolution, and this is the number of rows and number of columns. Okay, so you are resampling the raster, okay, in order to assure that you have the same dimension. Okay, 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 and now we have to reproject, and this reproject is close to what we have done here. Okay, so because I'm kind of lazy, I don't want to. Okay, reproject source, rasterio, band, source 1, destination, destination 1, src transform, src transform, src crs, src crs, this transform, this will be the new transform, the destiny, the destiny crs, we are working with the same system of reference because we are just resampling, and this we are going to use the resample bilinear. Bilinear. Okay, rasterio. Okay, great. So now total bound. This is total bounds, my friend. SRS, donde SRC. This is SRC. Okay, so what we have is the resample. Okay, here we have the resample NDVIs. Okay, great. So now we are going to create another column. Okay, so we go here to scripts and then we create another one that is going to be called part 2. Okay, in this part 2 we are going to copy the libraries because okay, so here we have Rasterio, OS, plot, CRS, plot, NumPy, mask, calculate, okay, and here I think that we are going to do Fiona. Okay, great. So we are going to create the NDVI date list. We need that as well. Okay, I have parted that into two scripts because otherwise it will be too lengthy. Okay, and now we have another function to create the min NDVI. So, and since I'm kind of lazy, okay, I'm going to copy this, okay, and then I'm going to paste this, and this will be calculate min NDVI. Okay, calculate apps. Calculate min NDVI. Okay, now we are going, now that we have all the rasters of the same size starting from the same place, okay, we are going to calculate the min NDVI. Okay, I do the min NDVI because I want to decrease the outliers, okay, and this is in order to improve my algorithm. Okay, otherwise I can just take one NDVI and this will be much easier. Okay, so this is no, actually not. Raster one path is equal to post path join rst ndvi resample comma raster one. Okay, so we are going to open from the resample. This is for the raster one and this is for the raster two. Okay, the rasterio object is rasterio.open on raster one path. Okay, now we read the band as type. Okay, and now we get the mean in dBi. Okay, and solving the zero when you have some values of zero. Okay, when you have some values of zero, it will be zero. Okay, so the ndvi image is equal to rasterio dot open of rst. Okay, and it will be ndvi mean slash wildcard s of raster name. Okay, this will be the raster name. On the type is w. The driver tutorial, they ask me for tutorials. It's actually no. There are some tutorials in Python of the ndvi, but what you have to do, Angie, is to look for the documentation of Rasterio. Okay, this is what is most important, because no, there is not, okay, or at least I haven't, okay, read any specific book. CRS is equal to raster1.crs transform is equal to transform. Okay, okay, now we calculate the ndvi from ndvi daily 0. And this will be called ndvi 2013 is the mean value, no, of the 2014. Okay, let's see if this works. Wait. Uh-huh. Ah, okay. This is NDVI repro. Okay, great. And now read one. This is raster 2. Read one. Only have one. Okay, so it has created that for the min NDVI, and then will be 2 and 3, and it will be the NDVI 2033. Okay, and now we are going to make the difference. Okay, the difference in between those NDVIs, the calculate NDVI difference of raster 1, raster 2, raster name, and threshold. Okay, why difference? Because we want, okay, we don't want all the values, but we want the values that have changed in between certain threshold. Okay, so we need this raster 1 path is NDVI min. Raster 1 band minus raster 2 band okay. So when the difference is higher will be the difference, otherwise will be an empty value that will be minus 9999. Okay, so and say, and here we have the NDV image. So the NDVI image is equal to rasterio dot open dot NDVI min raster name w gtif raster 1 height count raster 1, and the type is flow, and here we have the no data. Okay. Mhm. Okay. Okay, there is a question from Sebius that says, does NDVI difference refer to any change on the DVI over time range or as long as above that? As long as above the threshold. Okay, so yeah, because there are no that amount of images. Okay, so you can have, okay, you can opt or you can do that with ranges. Okay, like if you have like for a certain time the rate of change has reaches that value, you can also work on that. Eh, but you have to, I mean, you how do you call it? You have to plan, you have to put your hypothesis, okay, before. The threshold is mm, this is based on the quantile because I think that the maximum value was 0.23. So if I get the threshold of 0.1, okay, if I have bigger thresholds, like the areas will be much smaller. Okay, it was kind of arbitrary. Okay, so now and then you can go to next part. Why? Because on the material, the on raster you have the NDVI mean. On the NDVI mean you have the difference, okay, that is the result of the what I have it before, and then we can explore that with QAS. Okay, so everybody open your QAS, please. Okay, so everybody is opening their QAS. Okay, okay, so here I have my QAS. I go to the webinar folder. Here on documents, I have the webinar. And I have scripts. Now I have the rasters. I have the NDVI mean. And here I have the difference. Well, you have, okay, uh, you have the wait, this is diff. You have it with only one F, and then I have it with two Fs. Okay, so you have this file and I have this file. Okay, that is the same. And here are the values, okay, that I will point with the, I will add a Google satellite on the back. Okay, okay, and here are the values where the NDVI has decreased more than 0.3, okay, on the last 10 years. Okay, so and as I mentioned, this was done in purpose to do the surveys on the field, and it's a great tool in order to start. Okay, where you see some more drastic things when you have crops, because in these parts, okay, so if you see the image 10 years ago, for example, their shrubs are still are alive. Okay, now they are dry. Okay, so that will be everything for today webinar. Do you have any questions? Do you have any questions? Okay, just say goodbye in the chat and